Let's revisit the example that we saw before with one firm, one consumer, and let's assume that the cost function has the properties that it is decreasing returns to scale and that there are no fixed costs. So the fixed cost and the semi-fixed cost are equal to 0. I want to show you how the properties, the formulas that we have just derived, apply in this case. So now let's do the drawing that we did before. I'm just repeating it very quickly with these assumptions on the cost function. This is the amount of Q that the consumer consumes. This is the amount of M. And the feasible set is going to be given by this curve. Okay. And the way to generate it is the consumer can choose, we can give the consumer, a 0Q and the endowment in M, or then we can trace this line, and any point that has an amount Q also means that we have to take away from the consumer C of Q, which means that he only gets to consume this much of good M. And all of these points, including things down here, are feasible. Notice, just for your intuition, that the fact that the cost function is decreasing returns to scale means that this is bending in just this precise way. Every additional unit of Q that we want to give the individual is going to cost more and more M. So we need to, for another way of saying that is for every unit of M that we go down, the individual get progressively less and less additional Q. And that explains the bend. Notice that since this has equation, this line has an equation, W minus CQ, the slope here, the slope of the line is minus C prima of Q. That is the slope of this feasible set line. Now let's look for a second at the preferences, and we're going to look at this in different sets, and this is going to be the point that we said before was the Pareto optimal. Remember, these are in different sets, so these are combinations of Q and M with constant utility. So, oops, utility. Ay, the Spanglish. What does that mean? That at any point, if we want to calculate the slope, let's say, what is the dm associated with any dq, we can do it by taking by doing the following, which we say, what is starting at a point, what happens if we increment by delta q, we're going to get the change of the utility increased by b prima dq. What happens if in addition we do a change delta m, then it's going to increase just by dm, because remember the utility function is bq plus m, and we want this to be equal to 0, so we can stay in the indifference curves, but this implies that dm divided by dq is equal to minus b prime of q. So the slope at any point is minus bq. Now let's look at the conditions for Pareto optimality. Let's look at here at Pareto optimal allocations. I hope you can see easily that conditions P1 and P2 do not bite because there is only one consumer and one firm. So there is no issue about how to allocate production or consumption across firms. But the one that does bite is this condition of optimal production, which for an interior allocation in this case says that B prima at the quantity given to the consumer, I'm ignoring the subscripts since there is only one consumer and one firm, has to be equal to C prima at the amount produced by the firm. That's what we need. And that's exactly the condition that we identified graphically in this case. So the purpose of the example was just to show you how the graphic intuition we derived before is exactly the same thing that is captured by the formula, in this particular case by property number 3. I want to emphasize that in the same previous example, it's possible to have corner Pareto optimal allocations, and that's a case that would look like this. We have the amount of M, the amount of Q, the feasible point 0W, and then suppose that you have that the feasible set looks like this. So it's a feasible set. And that the indifference curves here basically are flatter. So let's say they look like this. So they don't cross here, that's the key. So in this particular case, this is the unique Pareto optimal allocation. Now let's look at what are the first order conditions here. What we have is that this is a steeper, the feasible set, so we have that minus C prima of what the firm produces, which is 0, has to be is steeper, so it's more negative than B prima, which is also going to be negative of 0, which is equivalent, of course, to a case in which the marginal cost of the first unit is greater than the marginal benefit of the first unit, for this case of one consumer, one producer. So that's a situation in which the Pareto optimal thing is just to produce no good Q. And the intuition should be obvious. If the consumer is here, you cannot improve his well-being by increasing production of Q, because the marginal cost is going to exceed the marginal benefit.